Hello. Today we'll look at equations with absolute value. Before we get into the equation part, I think we need to understand what is absolute value and how does it really produces these answers we obtain. So absolute value, first of all, is the way we write it, absolute value. Yeah. And when we write absolute value, we use two vertical lines. So the absolute value of A. Okay. So if I have this here, vertical line, X, vertical line, we read this as the absolute value of X. Okay. So these two lines here, is what makes it the absolute value symbol. Okay? And we can have equations also. So for example, if we have x plus 3 equals 7, then we will read this as the absolute value of 3 is equal to 7. Okay, so this is an equation. So just to point out to you what the symbol of the absolute value is. Now, what is absolute value? Well, the absolute value really means the distance from zero. Yeah. So absolute value measures distance from zero. And this is very important because, as you know, okay, distance, okay, is positive. So, for example, if I have the absolute value of 3, realistically what that means, okay, what that is asking, what is the distance on the number line from 0 to 3? So what is this distance here? And if you look at that, that is 3 units. Okay, this distance here is 3. So the absolute value of 3 is 3. Well, how about if we look at the example? What's the absolute value of -7? Well, if we look at the number line again, and the distance from here to 0, what is this distance? Now, although you're on the negative side here, this here would be 7 units, not -7. So the absolute value of -7 is also 7, or that is equal to 7. Yeah. Now, you will observe that if we continue to do this, okay, if I ask you what is the absolute value of 2, you will tell me that that answer is 2. And then I ask you what is the absolute value of -2, you will also tell me that that result is 2. Okay, if you do it on number line. So the absolute value, whatever is on the inside of the absolute value, okay, can be a positive or a negative, but the result is always a positive. Okay? And interestingly enough, if we play sort of like a little guessing game here, okay, sometimes we can look at equations and we can basically guess what's happening or what the result is. So if we play a guessing game, and the guessing game is guess the answer. So example, if I tell you that x plus 2 is equal to 5, your guess, what would you guess? Guess x should be equal to what? Now obviously you can do this in algebra, but if you think about it, what plus 2 is equal to 5? So your guess should be 3, right? If we look at another example here, x over 5 is equal to 2. If you guess x is equal to what number? What divided by 5 is equal to 2? Well, 5 divided by 5 is 1. So if you guess, you will see that x is 3. Now, here you have to be careful. Example, if I tell you the absolute value of x is equal to 4, okay, guess x is equal to what? Now, here when you guess, you have to be careful, okay, because we know that the absolute value, that x value, could be a positive number or a negative number. So here, your guess would be x is equal to 4 or x is equal to -4. Because the distance from 4, okay, if we look at this, okay, if here is 0, 1, 2, 3, 4, this distance here is 4. Likewise, -1, -2, -3, -4, this distance here is also equal to 4. So the x value could be -4 or +4. Yeah. So in general, what we do, okay, to save time with your work, in general, this is important for you. Yeah. We can say that any equation of the form absolute value of A equals, let's say, B, is equivalent to the equations, okay, A equal B or A equal minus B, okay? So if you have, right, what this is saying, if you have an equation, the absolute value of A is equal to some number, okay, B. It means that this here could be a positive A or a negative A, okay? So what we do, you can think of this as, well, if A is positive or negative, and I split this up into two problems now, A is equal to B, that's the positive part, and minus A is equal to B. But if you take that minus to that side, you have A is equal to minus B. Okay? So this is one way of thinking about it. The key point is that anytime you have an absolute value equation, you will have to split it up into two parts. Okay? You will have to split it up into two parts. So we generally don't write this out the way I just did here. Okay? We can save the steps and say that the absolute value of x is equal to 4 means that two equations, okay, x is equal to 4 or x is equal to minus 4. So before you solve an absolute value equation, yeah, there's a few things you must note. So for example, if we now look at an equation and I ask you to solve, and I give you that equation, the absolute value of 2a minus 1 is equal to 7. Now, before you go ahead to solve, this is very similar to equation because once you split it into two, all absolute value equation will have to be split into two equations, as we did here, okay? But before you make that split, okay, there's a couple of things you have to know, okay? First, you should check, right, is the absolute value by itself. And what do we mean by that? Is this thing here by itself. There shouldn't be anything on the side, on the outside of it. Okay? Shouldn't be anything. Once that is by itself or isolated, okay, then we can split. Once that isolated, we can split it. And when we split, we have two equations now. These equations are 2a minus 1 equal to 7 and 2a minus 1 equal to minus 7. And you have learned how to solve equations already. Okay? So in our example, we will add 1 since we're going across the equal sign. So we have 2a is equal to 8. And then to get a by itself, we'll divide both sides by 2. And this would leave us with a is equal to 4. Now, this is not an answer. You still have to do something. Okay? Let's look at the other side. The other side, because you have to solve both sides, you will add 1. These will cancel. So you have 2a is equal to now minus 6. Yeah? And then you divide both sides by positive 2. These will cancel. So you have A is equal to -3. And this is possibly an answer too. Now, you're not done. Okay, very important. Not finished. Okay. Anytime you have an absolute value, you must check your answer. Okay. So we have to check. We have to check if A is equal to 4, and we also have to check if A is equal to -3. So we go back to our given equation. The equation we had was the absolute value of 2A minus 1 is equal to 7. 2A minus 1 is equal to 7. Okay. We have to perform the check twice because you will see that sometimes the answers are not possible. So let's check this. Okay. We have the absolute value of 2, and remember A is 4 minus 1. Absolute value of that is equal to 7. So then we have 2 times 4 is 8. 8 minus 1. 8 minus 1 is 7. And the absolute value of 7 is 7. So this check. So A equals 4 is an answer. Okay? If it does not check, you have to omit that answer or throw it out. That's very important. So let's check now our other answer, possible answer. So we have the absolute value of 2, and in this case, A is -3. Okay? So 2 times -3 becomes -6 minus 1, absolute value of that. -6 minus 1 is -7. The absolute value of -7 is 7. So 7 is equal to 7. That also check. So in this case, A is equal to -3 also. So our two answers is A equal 4 or A equals -3. Those are two answers. Okay. So two things to note as of now. Okay. Anytime you're solving an absolute value equation, you will have to solve two equations, as we did here when I say we split. Okay. And when you're finished solving your equations, you have to check your answers. Okay. Those two things are extremely important as you work with absolute values. Let's look at another example. I would like you to solve the absolute value of 8 minus 7y plus 9 is now equal to 1. Okay. Now remember what I said before. You have to remember what I said. You can only split this if the absolute value is by itself. Okay. So earlier we had this comment. Check if the absolute value is by itself. Okay. So check if the absolute value is by itself. Okay. And then if it's not, if it is not, you must move, okay, items to leave the absolute value by itself. Okay, so in this case, here is my absolute value. Okay, here is my I want to leave this here by itself. So it means I have to get rid of that plus 9. So we have the absolute value of 8 minus 7y plus 9 is equal to 1. Now, since I'm going across the equal sign, I will minus 9 on both sides. And if I do this, I have the absolute value of 8 minus 7y is now equal to negative, okay, 8. So now my absolute value is by itself, okay? Now I want you to pay attention here because you will see something towards the end of this problem. We said before that the absolute value, okay, of anything is positive, right? This has to be equal to something positive. And here we're saying it's negative 8. Well, let's solve the equation and see what happened. In addition, now that my absolute value is by itself, I can split it. Okay, I can split. And what we have is 8 minus 7y is equal to negative 8. And 8 minus 7y is equal to positive 8. Okay. Now, let's solve. So if we minus 8 on both sides, this leaves me the plus 8 and the minus 8 cancel. Minus 7y is equal to minus 16. Okay. And then to leave y by itself, we'll divide both sides by negative 7. And this will give us the negative 7s will cancel. Y is equal to 16 over 7 because the two negatives become a positive when you divide. So this is one possible answer. We'll check it in a minute. Alternatively, if we look at the other side of the equation, we're going to minus 8 on both sides. If we do that, the plus 8 and the minus 8 cancels, so we have minus 7y is equal to 0. And then if we divide both sides by minus 7, the minus 7 becomes 1. So here we have y, anything, if there is a 0 in the top, the answer is 0. 0 divided by the number is 0. So here is another possible answer. Now, let's check, okay? Remember, we have to check. Remember what our original equation is. Our original equation is the absolute value of 8 minus 7y plus 9 is equal to 1. Okay? Or, if you wanted, you saw when you brought this to that side, you had the absolute value of 8 minus 7y is equal to minus 8. Either one of these two you can use. It doesn't matter. Okay, so let's check. Remember, we're checking that y is equal to 16 sevenths. And we also want to check that y is equal to 0. So if we perform our check, we have the absolute value of 8 minus 7. And remember, the value of y is 16 sevenths. That must be equal to minus 8. So simplifying this, you have 8, this negative the 7, and that positive 7, right? It still becomes a negative, but it's 16, and that is equal to negative 8. 8 minus 16 is negative 8. But the absolute value of a negative quantity, right? Remember, absolute value means distance. This is 8. So 8 cannot be equal to negative 8. So this is not a true statement. Okay, this is false. So y equals 16 over 7 is not a solution. Okay, is not a solution. Now, if we check the other side of this, let's see what happens. 8 minus 7, we're going to replace y with 0. Okay, and that is equal to negative 8. Okay, and if we do this, um, we have the absolute value, negative 7 times 0 is 0, and 8 minus 0 is 8, and the absolute value of 8 is 8. Once again, we see that 8 is not equal to negative 8. So this is also false. So y equals 0 is not a solution. So conclusion here is this problem has no solution. You would have, this is what I tried to point out earlier, okay? What I pointed out earlier is that if you have an equation, okay? So note, we had the absolute value of 8 minus 7y plus 9 is equal to 1. And when we moved this minus 9 to both sides, okay, if we move it to the right side, we have the absolute value of 8 minus 7y is equal to minus 8. And something to note here is that the absolute value of any equation has to be equal to something that's positive. Otherwise, we will have no solution, because the absolute value of any quantity is a positive answer. Okay? Whatever is in this absolute value must be positive. But even if you didn't see that at the beginning, okay, even if you didn't see it, as you solve and check, you will see that your answer would be false. Now, be careful about what I just said, because sometimes we say things and then when we look at them, it appears to be different, right? And the reason I'm saying that is because if you look at my next example, solve, the absolute value of 4x plus 2 minus 10 is equal to negative 2. Now, because you see a negative 2 there, you may think, oh, there is no solution. But that's not true, because the absolute value here is not isolated. So the first thing you must do, you have to move that 10. And if you move that 10, you will see that we have the absolute value of 4x plus 2 is now equal to 8. And now this will have possible solutions. Now, since it's by itself, we can split it into two. Okay? We can split it into two. So we have 4x plus 2 is equal to 8, and 4x plus 2 is equal to minus 8. Okay? Solving each side, we minus 2 on both sides. So we have 4x is equal to 6. And then we will divide both sides by 4. The 4's will become a 1x. So x is equal to 6 over 4. But keep in mind, x equals 6 over 4 can be simplified by dividing the top and bottom by 2. So we have 3 over 2. Likewise, solving the right side of this, or the right part of this, I would say, we bring down the 4x, the plus 2 and the minus 2 will cancel, and that will give me minus 10 now. And now we divide both sides by 4. So this will become a 1. So we have x is equal to minus 10 over 4, which can be simplified again by dividing top and bottom by 2. So you have minus 5 halves. Now keep in mind, you have to check them. You are never finished unless you check. Okay? So we have to check. So let's check. And we want to check, see if x is equal to 3 halves. And we want to check, see if x is equal to minus 5 halves, because both of them must be checked. Okay? So remember I said you could use either one of the equation, the simplified version or not. It doesn't matter. So if we use 4x plus 2 minus 10 is equal to negative 2. Doesn't matter. So by doing this, we have 4. Instead of x, I'm going to write 3 halves, okay, plus 2, and then minus 10. Does that equal to negative 2? Well, if you multiply 4 times 3 halves, you get 12 halves plus 2 minus 10. 12 halves is the same as 6. 6 plus 2 is equal to 8. The absolute value of 8 is 8. And 8 minus 10 is negative 2. So negative 2 is equal to negative 2. That's true. Therefore, x equals 3 half is an answer. It's confirmed. This is an answer. Now we have to go and check if x equals minus 5 half is an answer also. So the absolute value of 4x minus 2 minus 10 is equal to negative 2. Now, the absolute value of 4, now our x value is minus 5 halves. Yeah? And if we multiply this, this becomes minus 20 halves. Yeah? And minus 20 divided by 2 is negative 10. Minus 10 minus 2 is minus 12. The absolute value of minus 12 is positive 12. 12 minus 10 is negative 2. 12 minus 10 is 2. Okay. So here we have 2 is equal to negative 2. And this is not true. Okay. So, conclusion here, x equals 5 halves. That's what it was, right? 5 minus 5 halves. Okay, x equals minus 5/2. So notice I've just observed that the original equation, this here is a plus, over here I wrote a minus, so this should have been a plus. Okay, and then this becomes incorrect here. Minus 10 plus 2 is minus 8. Huh? So that's minus 8, so that means we have to remove this. There's an error. The absolute value of minus 8 is 8, and 8 minus 10 is minus 2, and minus 2 is equal to minus 2. So x equals to minus 5/2 is also a solution for this problem. So we have to be careful because the check, especially with the fractions, it's very easy to make mistakes. And then also make sure when you copy back the problems I did, you make sure you copy the correct problem. Okay? So let's look at another example. Okay. Solve 3 absolute value 2x plus 4 minus 5 is equal to 7. So as you can see, the absolute value here is not by itself. So we want to move plus 5 to both sides. Okay. If we do this, we have 3 absolute value of 2x plus 4 is now equal to 12. Now, very common I find that students distribute this 3 to the inside of the absolute value, and that can never happen. So you cannot, if you have a number outside of an absolute value, you cannot distribute, cannot. Okay? Cannot. So this is wrong. So the only way you can do this is by dividing both sides by 3. Okay? So we have 3 absolute value of 2x plus 4 equals 12. Note the absolute value is still not by itself, so we have to get rid of that 3, and to get rid of the 3, we divide both sides by 3. By doing this, now the absolute value becomes by itself. And now I'm able to split the problem into 2. So it's very important that you observe that the only time you can split it is once the absolute value is isolated. Okay? So we have 2x plus 4 is equal to 4, and 2x plus 4 is equal to minus 4. Okay? If you solve, we'll move the plus 4 to both sides. So minus 4. Okay? This will cancel out. So we have 2x is equal to 0. Divide both sides by 2. So then we have x is equal to 0. In addition, we have to solve the other problem. So if we minus 4, we have 2x, this becomes 0, is equal to now minus 8. And now to get x by itself, we'll divide both sides by 2, and this will cancel out, so x is equal to -4. Yeah, x is equal to -4. So x can be 0 or x can be equal to -4. Now, remember, we're not finished. We have to check. Okay. And we can use the original equation, or we can use the simplified with the absolute value. So I'm going to use the one that's 2x plus 4 is equal to 4, right? We're using this one here. You can use this, or you could go back and use this one here. It doesn't matter. Okay. So now we want to check when x is equal to 0. So if we do this, we have the absolute value of 2. We're going to plug in x to be 0 plus 4 and see if that's equal to 4. 2 times 0 becomes 0 plus 4, and 0 plus 4 is 4. So we have the absolute value of 4, and the absolute value of 4 is 4, so 4 equals 4, that checks. So we know that x equals 0 is a solution. That is a solution. If we check x equals -4, okay, let's check x equals -4. So this gives me the absolute value of 2. Now we're going to plug in -4 for x. And 2 times -4 becomes -8 plus 4. -8 plus 4 becomes -4. But the absolute value of -4 is 4. So 4 equals 4, this check. Therefore, x equals -4 is also a solution. X equals 0 or x equals -4 are solutions to this problem. Yeah. Now, so we looked at different examples and we see that, we have to check. You must check. Now, if we look at our next example, you will see that we can have equations with absolute value on both sides. And what do we mean by absolute value on both sides? For example, if I have the absolute value of 3a plus 2 is equal to the absolute value of 2a plus 3. Now, here's another common error that I notice that's being done, is that people tend to cancel out the absolute values from both sides and then say, oh, they're equal and they just solve. But you can't do that. You have to remember, okay, that the quantity 3a plus 2 and 2a plus 3 have equal absolute value. That means they're the same distance from 0 on the number line. So we treat this the same way we did. Okay? What we do, we take the 3a plus 2 and we said that is equal to 2a plus 3, and okay, we say 3a plus 2 is equal to the negative of 2a plus 3. Okay, so I put it in parentheses here because you now have two terms in here. Yeah? And then you solve each one of these equations individually. Okay, So be careful, do not drop the absolute value and say since it's on both sides of the equal sign, they cancel out. That's not true. Okay. So remember, one side is positive and one side is always negative, as we did in all our previous exercise, okay, or examples. So if we solve, we have 3a plus 2 is equal to 2a plus 3. I always move the smaller a, so I will minus, okay? And if I minus my 2a on both sides, this becomes a plus 2 is equal to, this will become 0, 3. And then we minus 2 on both sides. And if I do that, this is 0, so we have a is equal to 1. So here is one possible solution. If we look at the other part of the problem, we have 3a plus 2 is equal to, distributing the negative, we have minus 2a minus 3. I always move my smaller, so plus 2a plus 2a. And if I do this, I now have 5a plus 2, this becomes 0, and that's equal to negative 3. And now we subtract 2 on both sides. So we have 5a, this becomes 0, is equal to negative 5. Okay? And to get a by itself, we will divide both sides by 5. And that becomes a 1. So a, we have a is equal to negative 1. But we are not finished. Remember, you have to check. Okay? You must check your answer. Check. So remember, we're checking into the original problem. The absolute value of 3a plus 2 is equal to the absolute value of 2a plus 3. Okay? And the first thing we want to check is a equals 1. And then we have to check a equals negative 1. Okay? If we do this, we have the absolute value of 3. And for a, we're plugging in 1. Simplifying this, 3 times 1 is 3. 2 times 1 is 2. And then if we simplify the inside, this becomes 5. This becomes 5. The absolute value of 5 is 5. The absolute value of 5 is 5. 5 is equals to 5 is true. So a equal 1 is a solution. That is a valid solution. Okay. We'll do the same thing and check when a is negative 1. So 3, now we're replacing our a with negative 1. 3 times negative 1 is negative 3. And we have 2 times negative 1 is negative 2. Simplifying the inside, this becomes the absolute value of negative 1. 2 plus 3 is 1. The absolute value of negative 1 is 1. And the absolute value of 1 is 1. And 1 is equal to 1. So a equals to negative 1 happens to be a solution also. So either one of these are solutions. Okay. So working with these examples, you can see that it doesn't matter, okay, you have to check your solutions because you never know when they are true or when they are false. Let's look at the last example. Solve the absolute value of x minus 5 is equal to the absolute value of x minus 7. So, as we said, since the absolute value is isolated, we get two problems. First, we have x minus 5 is equal to the positive part. And then we have x minus 5 is equal to the negative part. Okay. So distributing the positive sign doesn't change anything. And then we solve, we always move my variables first. So in this case, I'll minus x on both sides. When I do this, observe this cancel out. We have minus 5 is equal to, this cancels out, minus 7. And here we know this is false. So there's no solution here. Okay. Let's look at the other side and see what happens. So you don't even have to check anything in this part. If we distribute that negative, this becomes minus x plus 7. I always move my smaller variables, so I will add x to both sides. And this becomes 2x minus 5 is now equal to 7. Okay, 2x minus 5 is equal to 7. I will add 5 to both sides. That leaves me with 2x, this becomes 0, is equal to 12. And then to get x by itself, I will divide both sides by 2. Okay. This will become a 1x, and here we have 6. And now we have to check. So we want to check if x equals 6 is a solution to our absolute value equation, x minus 5 is equal to the absolute value of x minus 7. Remember, we don't have to check anything here because that was false, right? So we only have one check. So we have the absolute value, 6 minus 5 is equal to the absolute value of 6 minus 7. Well, if we simplify the inside, this becomes a 1. And if we simplify the inside here, this becomes a minus 1. And the absolute value of 1 is 1. The absolute value of minus 1 is 1, so this is true. So confirm x equals 6 is a solution. So very similar, it has a lot of solving linear equations here. Once you isolate the absolute value and get it by itself and splitting this. Okay, hopefully this was helpful.